whenever we go for something new, the existing system needs to have some flaws or some limitations. किसी भी existing चीज में कुछ drawbacks रहते हैं, then that is the reason why we go for some advancement, we go for some improvement. Similarly, today the topic that we are going to take is supercritical extraction. So the first and foremost thing that comes to your mind is what is supercritical and what is extraction. We'll take the introduction from there itself. What is extraction? Next, ma'am. So extraction is one of the most important mass transfer operations where we bring in contact two liquids. A liquid which is having a mixture of might be two or more than two components. We bring this in contact with another liquid which is immiscible, and a mixture of both these liquids is initially formed. As a result of which, after some time, some components from the initial mixture moves from the mixture to the solvent that we have added, and as a result we get two different solutions. हमारे पास एक mixture है liquid का, and we add a second liquid, as a result of which ये दोनों liquids का एक mixture बनता है, and finally दूसरा जो solvent होता है that is immiscible, as a result of which we get two different solutions. और कुछ components initial mixture में से they move to the solvent. Now most of you students are very much aware about what do you mean by mass transfer operation, what are the different types of mass transfer operation. In that, extraction falls in the category of an indirect method. Now what do we exactly mean by an indirect method? Extraction is something like you are having two components, two or might be more than two components in a mixture. आपको ये दोनों components को separate करना है, and for separating that you are actually using a third component. दो चीजों को अलग करने के लिए आप एक थर्ड कंपोनेंट ऐड कर रहे हैं. सो दिस माइट साउंड समथिंग स्ट्रेंज, क्योंकि प्रॉब्लम पहले दो से था, उसको सॉल्व करने के लिए आप अंदर तीसरा कंपोनेंट ऐड कर रहे हैं. दैट इज स्पेसिफिकली द रीजन व्हाई वी कॉल दिस एन इनडायरेक्ट मेथड. नाउ व्हेन विल दिस पर्टिकुलर मेथड बी एक्चुअली फिजिबल, और हम लोग एक्चुअली एक्सट्रैक्शन कब यूज कर सकते हैं? ओनली व्हेन जो इनिशियल सॉल्यूशन है उससे हमारा जो सॉल्वेंट और जो सोल्यूट का मिक्सचर बन रहा है, द न्यू सॉल्यूशन दैट वी आर मेकिंग, सॉल्वेंट को ऐड करने के बाद जो नया सॉल्यूशन बन रहा है उसका सेपरेशन अगर हमारे इनिशियल सॉल्यूशन के सेपरेशन से आसान है, देन ओनली दिस एक्सट्रैक्शन कैन बी टर्म्ड एज फिजिबल. आई होप इट्स वेरी क्लियर. ए और बी को मुझे सेपरेट करना है, ए और बी को मैं सेपरेट नहीं कर पा रहा हूं, एज अ रिजल्ट ऑफ विच नाउ आई एम एडिंग सी. सो नाउ आई गेट अ मिक्सचर ऑफ ए प्लस सी एंड सपोज से बी प्लस सी. अब ए प्लस सी का जो सेपरेशन है that has to be easier than the separation of A plus B. In that case only this concept of extraction can be used. तो ही हम लोग extraction का जो concept है वो use कर सकते हैं. और the biggest drawback of this indirect method is extraction के बाद हमेशा you need to carry out distillation. Why? आपके पास A plus B का mixture था, on that you added a component C that is your solvent, और आपको solute और solvent A plus C का एक mixture मिल गया. Now to separate the solute and the solvent you need to employ another method which has to be distillation, which is a direct method. Okay, direct method के अंदर हम लोग डिटेल में नहीं जाते. Indirect method means you are adding a third component और फिर आपको बाद में final separation जो है करना है. So another drawback, biggest drawback of extraction is that extraction process के बाद हमेशा आपको to get the final product you need to carry out distillation. That is one of the biggest drawbacks of extraction. That is the reason why again extraction is more energy intensive. It's more complex क्योंकि वो एक single unit operation से खत्म नहीं होगा. After that you need to employ distillation also. Now जब आप लोग extraction करते हैं उसके बाद distillation कर रहे हैं, the cost involved in this gradually increases, because when we are talking of distillation, distillation is a highly energy intensive process. उसमें हीट एनर्जी की रिक्वायरमेंट बहुत ज्यादा होती है. वी रिक्वायर अ लॉट ऑफ हीट इन रीबॉयलर एंड वी रिमूव अ लॉट ऑफ हीट. हीट बहुत ऐड कर दे रीबॉयलर में और बहुत ज्यादा हीट रिमूव कर दे यूजिंग कंडेंसर. सो इट्स हाईली एनर्जी इंटेंसिव. सो ये सारे हीट एनर्जी का जो चार्जेस एनर्जी रिक्वायरमेंट्स हैं, दैट आल्सो वी नीड टू ऐड व्हेन वी आर कंसीडरिंग द इकोनॉमिक फिजिबिलिटी ऑफ दिस पर्टिकुलर प्रोसेस. एंड फाइनली द बिगेस्ट प्रॉब्लम, एज आई ऑलरेडी सेड, जो सोल्यूट और आपका सॉल्वेंट है उसका 100% सेपरेशन बहुत ज्यादा मुश्किल है. इट्स वेरी डिफिकल्ट. आप 70, 80, 90% तक कर सकते हैं, बट इफ यू एक्चुअली वांट टू गो फॉर 100% सेपरेशन, जो फाइनल आप डिस्टिलेशन से सॉल्वेंट और सोल्यूट को सेपरेट कर रहे हैं, In that, if you need to have really very good separation or might be very pure product, हम लोग देखेंगे for which products generally we are using this particular supercritical extraction. लेकिन normal methods के अंदर अगर आपको extraction के बाद if you want to use distillation के अगर 100% आपको recovery चाहिए, the height of the distillation column is relatively very high. So as I said, there are a set of restrictions or set of limitations when we are using the conventional extraction process. And that is the reason why we need to develop. We had to find out another method, something different than this normal conventional extraction, which will overcome all these drawbacks. ये सारे drawbacks को overcome कर सके ऐसे एक method की जरूरत थी. That is the reason why we found out something. We termed something which is known as supercritical extraction. Next, please, ma'am.
Yes, sir.
Now, some terms we are actually aware of. So I would specifically like to discuss about two. That is, first is fluid, and second one is critical point. I think at least some of the students would be knowing the definition of fluid. जितने students को पूछा जाता है, most of the time whenever we ask them what is a fluid, they say liquid or gas. इन दोनों को fluid कहते हैं. But that is not exactly the answer. That might be an example. That might be a category for fluid. But fluid का मतलब क्या होता है? That is very important to understand. When you say a fluid is any substance which cannot resist deformation permanently. एक ऐसा substance जो उसके ऊपर अगर हम लोग pressure लगाते हैं, if you are applying some stress on it, it cannot resist the change in its shape or its structure. Permanently उसको resist नहीं कर सकता. That is what is known as a fluid. So obviously, liquids fall in the category of fluid, gases fall in the category of fluids. Now coming to the second important term, especially in terms of our supercritical fluid. What do you mean by the critical point? Critical point is again, also I think students might be knowing, for those who do not know. Critical point एक ऐसा point है. The temperature and pressure related to critical point are known as critical temperature and critical pressure. कोई भी component का जब आप temperature और pressure, when you increase the temperature or pressure of any particular component above the critical point, the distinction between the phases, जो liquid और gas phase जो है, उसके बीच में जो difference है, it is eliminated. उसके बीच में जो difference होता है, वो difference खत्म हो जाता है. It means the liquid and the vapor phase becomes identical. दोनों एक जैसे हो जाते हैं. Okay. Now this phase, these properties are very much useful. इसी क्या properties होती हैं? That is what we are going to see now. But we are actually trying to exploit these properties. ये जो properties है, उसे हम लोग extraction के अंदर use करेंगे, and that is what is the concept of supercritical extraction. Now, if I want to explain what is critical temperature, उसको भी slightly अलग तरीके से we can explain. For example, critical temperature. If you can see this particular graph, it is a graph of pressure versus temperature for water. Okay. So now suppose if we are talking about critical temperature, आपका जो पानी का जो critical temperature, if you increase the critical temperature of water above its critical temperature, अगर आप critical temperature है जो है पानी का, उससे ज्यादा उसका temperature बढ़ा देंगे, आप उसका pressure जितना भी ज्यादा कर लीजिए, however high you increase the pressure, you cannot convert water into liquid. वो supercritical state में रहेगा. आप उसको जितना भी high pressure लगा दीजिए, it will not get converted into liquid. Okay, that is the significance of critical temperature. So as a student, when we are trying to understand supercritical temperature as well as supercritical pressure, इसका importance, इसका significance क्या है, that we need to understand. Okay, next please, ma'am.
Yes, sir.
So now we are gradually starting about what do you mean by a supercritical fluid. ऐसी कौन सी properties हैं? Which are the properties because of which supercritical solvents, or here SCF, supercritical fluids, they have very much better properties as compared to the normal liquid solvents that we're using. Okay, पहली बात है is density. The density of supercritical fluids is very much similar to liquids. Liquids के almost similar रहती है. The density is sensitively changing with pressure. Pressure के साथ बहुत sensitively change होता है. If you change the pressure slightly, अगर pressure में थोड़ा भी फर्क आ जाएगा, In that case, the state, the density of the component of the fluid that we are talking, it changes drastically. So density is very sensitive to pressure, और जो इसकी density होती है supercritical fluid की, that is very much equal to that of liquids. Now coming into viscosity. Viscosity of a supercritical fluid is exactly similar to that of a gas. Okay, now when we talk of viscosity, viscosity का मतलब आपको पता है, viscosity means the resistance to flow. कोई भी component को आपको अगर pump करना है, if you want to make it move from one place to another, you require some energy. Viscosity जितनी ज़्यादा होगी, it means that more amount of energy is required for transportation of that substance. और आपको पता है, the viscosity of gases is very less. It means pumping gases from one place to another, it requires very less amount of energy. Okay, and as a result of which it offers very less resistance to heat transfer as well as mass transfer. Heat transfer और mass transfer बहुत आसानी से हो जाएगा when we are talking of viscosity being very low. Okay, और mass transfer happens basically because of concentration difference. Concentration difference की वजह से mass transfer होता है. और how does it actually take place? Mass transfer होता कैसे है? It happens by virtue of diffusion. There are different forms of diffusion, but basically it happens because of diffusion. So मैं ऐसा कह सकता हूँ, mass transfer के लिए diffusivity is one of the most important concepts. Now, the advantage of again supercritical fluid is that the diffusivity of supercritical fluids is intermediate to that of liquid and gas. जो liquids और gas है, उसके बीच में रहती है आपकी जो supercritical fluid है, उसकी diffusivity. The diffusivity of gases is very high, diffusivity of liquids is slightly low, लेकिन आपका जो supercritical fluid रहेगा, उसकी diffusivity liquids और gases के बीच में रहेगी. So now if you can actually analyze, अगर आप लोग समझ पाए, the advantages of using a supercritical fluid is that हमें वो सारी positive points मिलते हैं which are related to liquid as well as to gas. Liquids की density मिलती है, viscosity जो है वो gases की मिलती है, और diffusivity liquid और gases दोनों के बीच में है. It means it's not less than the liquid, it's not more than the gas. So diffusivity भी काफी अच्छी. These are the advantages which makes supercritical fluid very much suitable for using in our supercritical extraction. Next, please, ma'am.
Yes, sir.
So now, specifically talking, what are the technical advantages of using a supercritical fluid as a solvent against the normal liquid solvents that we are using? Okay, as I said, when you move the temperature and pressure of a component above its critical point, it moves into the supercritical state, जिसके अंदर liquid as well as gases का जो demarcation होता है, the difference between the liquid and gases, it ceases. They become like a common phase. So उसके ऊपर जाएंगे आप लोग, critical point के ऊपर जाएंगे, at that time these properties are nullified. So it means कि if you can bring down the temperature or pressure below this, it will again get converted into liquid or into gas depending upon the temperature and pressure. So it means that the supercritical fluids can easily and more importantly 100% आप उसको अपने extracted products और you can say अपने solute में से उसको 100% easily remove कर सकते हैं with very less amount of energy. Slight reduction in pressure or might be increase in temperature. Pressure आप थोड़ा reduce कर दीजिए, critical point के नीचे आ जाएगा. आप temperature थोड़ा increase कर दीजिए, again because of the temperature pressure relationship थोड़ा change कर देंगे. The supercritical fluids, they are separated from your extracted products. Okay, आपका जो extracted product है उसके अंदर से आपका जो solvent है that will easily get separated. It's very important to understand because in normal extraction, if you all guys know, solvent को solute से recover करने के लिए you need to use distillation. As I said, distillation it requires high amount of energy, heat देना पड़ता है, heat remove करना पड़ता है, tall distillation towers are required. It's a totally different unit operation. But यहाँ पे आप process के बाद you slightly reduce the pressure, you slightly increase the temperature और आपका solvent और solute 100% separate हो गया. It is one of the biggest advantages. Again, as we already saw, it has low viscosity and high diffusivity compared to liquid. Diffusivity जो है, जैसे हमने पहले बताया, liquid और gas के बीच में, so liquid से diffusivity सुपरक्रिटिकल फ्लूइड्स की ज्यादा है, विस्कोसिटी जो है लिक्विड से काफी कम है, and thereby it offers very less resistance to mass transfer and less friction in transportation. मास ट्रांसफर के अंदर डिफ्यूजिविटी हाई होने की वजह से लिक्विड से भी बहुत कम रेजिस्टेंस लगता है, एंड द फ्रिक्शन ड्यूरिंग ट्रांसपोर्टेशन इज आल्सो वेरी लेस बिकॉज द viscosity is relatively very low. Another very important technical factor that is useful as far as supercritical fluids are concerned is that they have very high value of selectivity. Selectivity जो है आपके supercritical fluids की, that is relatively very high. Now I'm not sure if you are aware of what selectivity exactly is, but just to give you an idea, selectivity is denoted by alpha. Selectivity represents कि आपका जो solvent है वो जो आपका स्पेसिफिक सोल्यूट है उसको कितने अच्छे से एक्सट्रैक्ट करता है, दैट इज व्हाट इज नोन एज सिलेक्टिविटी. इट मींस द रेशियो ऑफ सोल्यूट टू नॉन सोल्यूट इन माय एक्सट्रैक्ट स्ट्रीम टू द रेशियो ऑफ सोल्यूट टू नॉन सोल्यूट इन माय रेफिनेट स्ट्रीम. सोल्यूट आपका कितना आपके एक्सट्रैक्ट के अंदर आता है उसका सिंपल मेजर है सिलेक्टिविटी, विच इज डिनोटेड बाय अल्फा. सुपरक्रिटिकल सॉल्वेंट्स का सिलेक्टिविटी जो होता है इट्स एक्सट्रीमली हाई, बहुत ज्यादा रहता है. As a result of which this operation happens very easily. जैसे हम लोग कहते हैं डिस्टिलेशन के अंदर भी the term selectivity is generally used, relative volatility is used. अगर जो relative volatility है, if its value is 1, the distillation separation is not possible. Distillation possible नहीं है. If the value is slightly greater than 1, distillation is possible but difficult. Value जितनी ज्यादा होगी 1 से, the easier the distillation will be. उसी तरह से सिलेक्टिविटी जितनी ज्यादा होगी आपका ऑपरेशन उतना आसान हो जाएगा. इट मींस द सुपरक्रिटिकल सॉल्वेंट्स आर वेरी सिलेक्टिव ऑफ द प्रोडक्ट दैट यू वांट टू एक्सट्रैक्ट. आपको जो प्रोडक्ट एक्सट्रैक्ट करना है उसी को मैक्सिमम एक्सट्रैक्ट करेगा. द इम्प्योरिटीज इन दैट वुड बी रिलेटिवली वेरी 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 लेस. ओके, दैट इज वन ऑफ द बिगेस्ट एडवांटेज एज फार एज अगेन सिलेक्टिविटी इज कंसर्न. ओके, नाउ बहुत सारे सुपरक्रिटिकल फ्लूइड्स हैं. We will be taking the list of them. Some of the most commonly used ones also we will see. One of the most commonly used, सबसे ज्यादा जो use होता है, that is CO2. Carbon dioxide is one of the most commonly used supercritical fluids. Okay. Now, as I said, once you go through the extraction process, उसके बाद आपको अपने solvent और solute को separate करना है. At that time, what happens is for separation of the CO2, supercritical CO2 from your solvent, from your solute, you just need to reduce the reduce the pressure slightly and might be increase the temperature. And for CO2 we will see the conditions, it is done almost at the room temperature, almost room temperature के आसपास हो जाता है. It means you do not require very high temperature or energy. It's not an energy intensive process as far as temperature is concerned. Okay, so the cost of the process goes down drastically. अगर मैं CO2 स्पेसिफिकली की बात करूं, इट इज नॉन कोरोसिव एज वेल एज नॉन टॉक्सिक इन नेचर. जबकि हम बात करें हमारे जो सॉल्वेंट्स, कन्वेंशनल सॉल्वेंट्स होते हैं लाइक हेक्सेन, इफ यू आर टॉकिंग, दे आर हाईली फ्लेमेबल, दे आर हाईली टॉक्सिक. So a lot of care, lot of precautions has to be taken to avoid any hazards that can happen when you are using normal conventional solvents in any plant. Whereas जब भी CO2 की बात करूं, CO2 it's easily available, atmosphere में बहुत सारा available, you can collect that, sequestration can be done and you can use that. It's available in large quantity, it's available at a relatively cheap cost. It's non-corrosive when it's dry, it's non-toxic in nature. These are a load of different advantages that we have when we are talking of supercritical solvents, especially मैंने इसीलिए बताया. Right now, the last point that we have discussed is specifically with respect to CO2. सिर्फ कार्बन डाइऑक्साइड की जब हम लोग बात कर रहे हैं, these points are actually applicable. Next, please, ma'am. Now, always a coin has two sides. कोई भी एक पॉइंट आप बात कीजिए उसके बारे में हमेशा there will be some positives, some negatives also. Otherwise, आज फिर कहीं पे extraction यूज ही नहीं हो रहा था. Everywhere supercritical fluids and supercritical extraction would be the only thing in existence. कुछ disadvantages भी हैं आपके supercritical solvents के. Okay, the first and foremost is the poor value of distribution coefficient. एक हमने देखा that what do you mean by selectivity? Selectivity का मतलब selectivity बहुत high, मुझे जो चीज चाहिए मुझे वही चीज मिलेगी when I am using a supercritical solvent. But when I am talking of distribution coefficient, it means that the accuracy of the solute grabbing would be very high, but its efficiency would be relatively low. It means जो solvent to feed का जो ratio मुझे लेना है, that is very high. नॉर्मल कन्वेंशनल सॉल्वेंट्स को यूज करने में जितना करना पड़ता है उससे बहुत ज्यादा सॉल्वेंट मुझे यूज करना पड़ेगा when I am using a supercritical fluid. I can just try to compare this with a person who is very accurate, very minutely doing his work and is very punctual, but the speed at which he does his work is relatively very less. उसका काम जो है एक पर्टिकुलर एम्प्लॉय का अगर मैं बताऊं तो इट्स वेरी परफेक्ट. जो काम दिया जाएगा उसको 100% एक्यूरेसी के साथ वो काम करेगा, लेकिन उसको टाइम ज्यादा चाहिए. Exactly is the case with supercritical fluids. It will selectively procure the solute from your solution, लेकिन you need to use a very large quantity of your solvent. Solvent बहुत ज्यादा यूज करना पड़ेगा. Okay, that is one of the biggest disadvantage as far as your supercritical fluids are concerned. पिछले एग्जांपल एडवांटेज के अंदर हम लोगों ने लास्ट पॉइंट देखा, व्हाट आर द एडवांटेजेस ऑफ CO2. दैट्स व्हाई आई टोल्ड स्पेसिफिकली दिस वर द एडवांटेजेस रिलेटेड टू CO2. ये CO2 के एडवांटेजेस के अलावा आप दूसरे किसी सॉल्वेंट को ले लें, इन दैट केस फॉर द नेक्स्ट स्लाइड वी विल सी दैट द conditions of temperature and pressure that we require to maintain the component, the solute, the solvent in supercritical state is very high. Temperature बहुत ज़्यादा रहे, the pressure is extremely high. To maintain that pressure and temperature, the equipments required, the infrastructure required, the machineries required are very complex. A lot of care has to be taken to avoid any particular mishaps or disaster. So ये बहुत important है. CO2 के लिए it's easy to attain the supercritical state, but for some other solvents, for most of the remaining solvents, to attain the supercritical state is very difficult. बहुत ज़्यादा temperature और बहुत ज़्यादा pressure की जरूरत पड़ती है. Okay, we'll see that in the next one. Again, extraction जो process है in general, उसका एक बहुत बड़ा advantage ये है that you are having a wide range of solvents to select from. आप बहुत सारे सॉल्वेंट्स के अंदर से आप कोई भी पर्टिकुलर सॉल्वेंट सिलेक्ट कर सकते हैं व्हेन यू आर टॉकिंग ऑफ कन्वेंशनल एक्सट्रैक्शन. बट जब सुपर क्रिटिकल सॉल्वेंट्स की बात करते हैं, द सिलेक्शन, द रेंज इज नैरोड डाउन टू वेरी मार्जिनल वैल्यू. जो नंबर ऑफ सॉल्वेंट्स अवेलेबल है फॉर सुपर क्रिटिकल एक्सट्रैक्शन, दे आर रिलेटिवली वेरी लेस, बिकॉज एक जो आपको पता है, इट हैज टू बी feasible range of critical pressure and temperature, or the number of components available are relatively less, as a result of which आपके पास choice supercritical fluids की they are relatively very less. Okay, again certain supercritical fluid solvents they are flammable. इसको specifically एक disadvantage कहना मुश्किल है, because when we are talking of normal conventional solvents also, they are also flammable. Many of them are flammable, many of them are toxic. But जब हम लोग बात करते हैं supercritical fluid solvents की, why it is very important to mention that these are flammable is because the temperature and pressure conditions are very harsh. अब बात कर रहे हैं 100, 200, 300, 400 डिग्री सेल्सियस टेम्परेचर की. अब बात कर रहे हैं might be 50, 60, 70, 100 बार प्रेशर की. At this extremely high temperature and pressure, you cannot afford to make slightest of the mistake, because it can lead to very big catastrophic situation. इसीलिए supercritical fluid solvents अगर वो flammable है, you need to take extra high precautions to ensure that there is no accident that is coming up your way. Okay, next please ma'am. Now these are the list of some of the commonly used supercritical fluid solvents. Okay, might be there are some more, but I have just tried to put some of the things that are easily understood, as well as easily to identify what are the advantages as well as disadvantages of supercritical solvents. The first one, as I already mentioned, is carbon dioxide. Carbon dioxide का supercritical temperature है 31 degree Celsius. It means if you increase the temperature of carbon dioxide by 31 degree Celsius and you increase its pressure above 73.77 bar, in that case, carbon dioxide is now a supercritical fluid. जैसे मैंने स्टार्टिंग में बताया था, if you remember that if you want to separate सुपरक्रिटिकल कार्बन डाइऑक्साइड फ्रॉम माय सोल्यूट, मुझे टेम्परेचर थोड़ा बढ़ाना है, आई जस्ट नीड टू इंक्रीज द टेम्परेचर स्लाइटली. सो 31 से अगर टेम्परेचर बढ़ाना है, इफ आई वांट टू मेक इट इवन 35 और 40, दैट्स वेरी क्लोज टू रूम टेम्परेचर. सो अराउंड 40 डिग्री सेल्सियस पे अगर मैं मेरा सोल्यूट और सॉल्वेंट सेपरेट कर पाता हूँ, एंड दैट आल्सो विद ऑलमोस्ट 100% एफिशिएंसी, दैट्स अ वेरी गुड थिंग. It's highly energy intensive. Okay, I'm talking in terms of separation of the solute and the solvent. Okay, now this is the reason why we term it as the most favorable one. Carbon dioxide advantage हमने पहले भी देखे, they are non-corrosive, non-toxic, easily available. All those things are already there. Compared to that, let's come to the next one is xenon. Temperature is more comfortable. It's just 16.6 degrees Celsius. और pressure जो है, that is also very much comfortable, 58. But what is the problem? Xenon is having extremely high cost, और उसकी availability जो है, that's also relatively very less. So it can have, that might be as gradually the supercritical extraction becomes more and more widespread, it becomes more and more rampant, the cost might come down and its availability might gradually increase. But as of now, we can see that the temperature is also very much convenient. The pressure is also relatively less as compared to the most favorable, that is carbon dioxide. The only hindrance, the only roadblock that we are having is that of high cost as well as poor availability. Next one in this is ethane. Temperature again very much favorable, 32.27. Pressure again much more favorable as compared to the previous two. But again, ethane is inflammable. It can catch fire. So at this temperature, at pressure, if it catches fire, the pressure is 48 bar. 1 bar is almost equivalent to 1 atmosphere. 48, 49 atmosphere pressure पे अगर आपका ethane, if it catches fire, it can lead to a very big explosion. That is one of the biggest drawbacks of again ethane. Otherwise, ethane can be commercially manufactured with no much hindrances. But inflammable is one of the biggest properties that we have with ethane. Water, one of the most widely available and easily available low-cost commodity as far as chemical engineering is concerned. Problem क्या है? The critical temperature of water is 375 degrees Celsius. Much, much, much more. And what is the critical pressure? That is 221 bar. The conditions are really difficult, really difficult. 375 degrees Celsius or 220 pressure. 220 atmosphere pressure means अभी हमारे ऊपर जितना pressure लग रहा है उसका 220 times. You can imagine the condition. Okay, these conditions are very difficult. Again, being water, आपके पास water हो, आपके पास temperature हो, आपके पास pressure हो, the chances of corrosion increases 10 times, n number of times. It increases n folds. So the water along with the temperature pressure conditions make it highly corrosive. और दूसरी बात, high latent heat. इतने वाटर को जब आप लोग इस टेम्परेचर तक लेके जाएंगे 374.15, आफ्टर 100 डिग्री सेल्सियस वाटर विल बॉयल. So to increase the temperature to 375, extremely high amount of heat is required, extremely high amount of energy is required. Obviously 221 pressure जो है वो ले जाने के लिए भी require a very large amount of energy through pumps, and the heat required to increase the temperature to 375 is also very high. This is the reason why water is not used much. Otherwise, carbon dioxide से भी easily available is water, and might be water can yield much better results and it would be convenient in many other ways. But because of these difficult conditions, corrosive nature as well as high latent heat, water is not the most preferred one. In fact, water is one of the non-preferred one. Okay. One more has been listed here, propane. Temperature 96 might be okay. Pressure 42, okay. But again, as ethane, it's also inflammable. Hydrocarbons, generally, they have this biggest drawback. जो भी hydrocarbons, the alkanes, series, paraffins, whatever you talk of, they are generally inflammable. So, inflammable चीजों को जैसे आप उसका temperature increase करेंगे, जैसे आप उसका pressure increase करेंगे, the chances of catching fire increases. And more the temperature, more the pressure, if it catches fire, higher will be the accident that can happen. Okay, so this list just gives us some idea. As I already said that this list is not exhaustive. इसके अलावा भी काफी सारे supercritical fluids हैं. Here, the ones which I have mentioned is just to make us realize what are the advantages, disadvantages, and the general conditions of temperature and pressure for different fluids to attain the supercritical state. Okay, I hope this gives you a rough idea as to what are the temperature pressure conditions and why we are using carbon dioxide more, why we are not using xenon, why we are not using ethane, water or propane. Okay, next man. Now just this is a general flow sheet of what supercritical fluid extraction looks like. ये एक जनरल फ्लो शीट है जिसके अंदर से हमें एक आइडिया आएगा कि एक्सट्रैक्शन कैसे होता है. Okay, now this is basically a batch process where in the batch extractor you have already loaded the material which has to be extracted. जो material से आपको कुछ extract करना है आपने उसके अंदर already batch fill कर दिया है. If you can see the CO2 vessel के अंदर हमारे पास carbon dioxide है. From there it is pumped into the chiller. CHW is the chiller where initially the temperature of CO2 is brought down. आपको पता होना चाहिए when I told you regarding the supercritical state as well as supercritical temperature and pressure, मैंने बताया था अगर किसी चीज का टेम्परेचर सुपरक्रिटिकल टेम्परेचर से ऊपर पहुंच गया आप उसको कितना भी हाईली प्रेशराइज करेंगे that will not be converted back into liquid state. वो liquid state में convert नहीं होगा if आपने उसका टेम्परेचर सुपरक्रिटिकल से बढ़ा दिया तो. So इससे आपको पता चलना चाहिए that first we would increase its pressure above the supercritical and then we will increase its temperature above the supercritical temperature. Okay, so पहले हमने CO2 को नीचे लिया, we took it into the chiller, we reduced the temperature because जब भी आप किसी चीज को प्रेशराइज करते हैं its temperature is bound to increase, उसका टेम्परेचर थोड़ा बढ़ेगा. So हमने पहले उसका टेम्परेचर जो है we already reduced that. So when you are reducing the temperature, the CO2 gets converted into liquid and we have liquefied CO2. ये liquefied CO2 को I take it into the positive displacement pump, liquid pump, and I increase its pressure. इसका pressure जो है मैं liquid का बढ़ा के I increase it beyond its critical point. So जो liquid pump है, liquid pump में से जो आपका CO2, liquid CO2 जो बाहर आएगा, that will be having a pressure above its critical pressure. लेकिन उसका टेम्परेचर जो होगा वो क्रिटिकल टेम्परेचर से कम होगा. Now what will happen after this? To attain the supercritical state, now उसका टेम्परेचर जो है I need to increase the temperature beyond the critical temperature. So now I will pass that through a heater and I will increase its temperature and I will take its temperature to its supercritical temperature, that is 31 से ऊपर जो है उसका टेम्परेचर लेके जाऊंगा. So the CO2 that comes out from the heater is supercritical CO2. Its temperature is above the critical temperature. Its pressure is above the critical pressure. ये CO2 supercritical CO2 को मैं introduce करूंगा inside the batch extractor, where already the substance to be extracted is fed in. Feed हमने already उसके अंदर भर के रखा हुआ. Now the raffinate is going to go down from the bottom, but उससे पहले जो हमारा extract है, that is supercritical solvent plus my solute, ये दोनों ऊपर से जाएगा and it would first go through a heater where its temperature is slightly increased. Temperature उसका थोड़ा हम लोग बढ़ा देंगे. Slight reduction in temperature will lead to the separation of components. जो solute और मेरा supercritical जो solute है और मेरा जो supercritical solvent और मेरा solute, both of them will separate and then I will pass it through a pressure reducing device. जो उसका pressure है वो reduce कर दूंगा. If you remember, we discussed in the initial slides, slight reduction in pressure and increase in temperature. Temperature मैंने थोड़ा बढ़ा दिया, pressure जो थोड़ा घटा दिया. CO2 now is not in supercritical state. जो CO2 है, now it is not supercritical CO2, it is normal CO2 at the given temperature and pressure. वो जाएगा आपके separator के अंदर, and from the separator immediately your solute will separate and it will come down, and the CO2 that we get, जो CO2 है आपका, that will be recycled back to the CO2 vessel. This is the entire cycle. Now for a given component, generally CO2, this supercritical extraction is used for extracting different aromatic compounds from plants, medicinal compounds from plants, as well as roots, herbs. ये सारी चीजों में से to extract the components, supercritical extraction is used. So if suppose I am charging 100 kg of any particular product, based on the composition, I know that might be 2% of solute I will get. So 2 kg is the amount that I am going to get, for example. और मुझे शुरुआत में suppose say initially I get might be 100 grams, 200 grams, 300 grams. As long as I don't get the adequate amount or total amount of solute that is there in the batch, I will keep on recycling the CO2 और ये process होते रहेगा जब तक the adequate amount or the expected amount of the solute is not attained. Solute जब तक नहीं आ जाता, I will keep on recycling the CO2 and continuing this process. Once I find that जितना solute मुझे चाहिए था और what was expected has already come out, in that case, now I will stop the process. I will depressurize the system. अगर आपको याद हो तो pressure was around 70 बार के ऊपर का pressure था. So now this system is under extreme pressure. System मैंने बंद कर दिया. The process I have stopped. I am depressurizing. I am reducing the pressure. Then I open my raffinate. I collect my solute and the feed जो है उसके अंदर से the batch would again be cleaned up and the next batch would be filled. I hope this particular process gives us an exact idea of what supercritical extraction is, or in this particular flow sheet, the most important thing that we need to remember is normal CO2 को CO2 vessel से लेके हम लोग किस तरह से supercritical CO2 में convert करते हैं, that is the most important thing. Initially, you reduce the temperature. Why? अगर शुरुआत में उसको लेके हम लोग directly, if we put it in a pump, positive displacement pump, where the pressure increases above its critical pressure, उसका temperature बढ़ेगा. और अगर उसका temperature उसके critical temperature के ऊपर चला गया, in that case, ये CO2 को फिर liquefy करना possible नहीं होगा. So that is the reason why initially we reduce the temperature. We convert the CO2 gas into CO2 liquid. Liquid को हम लोग pressurize करते हैं and we increase the pressure above the critical pressure. उसके बाद हम लोग उसका temperature increase करते हैं and we raise its temperature above its critical temperature. And that is how finally CO2 is reaching its supercritical state. Okay. Next, please, ma'am. So this was a general description of normally what supercritical fluid extraction process looks like. As I said, there are some very good applications or very specific applications of supercritical extraction. अब हर दूसरे process के अंदर आप लोग supercritical extraction use नहीं कर सकते. We already saw the disadvantages. The conditions are very harsh. The initial investment cost or the capital cost of the process would be relatively very high. Because extremely high pressure को handle करने के लिए you require specialized equipments as well as machinery. So उसका initial cost, capital cost would be relatively very high. So specific चीजों के लिए where you require very pure solutes, उसी जगहों पे हम लोग ये process करते हैं. One of the best applications of supercritical extraction is that of decaffeination of coffee. Coffee beans के अंदर initially when you get the coffee beans, the quantity of caffeine एक content है which is present in coffee, and that caffeine is responsible for a lot of things that happen. Coffee हम लोग जो पीते हैं, हमारा जो it boosts our energy, it reduces drowsiness. जो benefits हम लोग coffee से मिलते हैं, that is basically because of the component known as caffeine. लेकिन initially जो है caffeine का content आपके coffee beans के अंदर ज़्यादा रहता है, and we need to reduce this to ensure that it does not harm the humans when they consume this coffee. तो इसीलिए कॉफी बीन्स के अंदर से कैफीन का जो कंटेंट है उसको रिड्यूस करने के लिए सुपरक्रिटिकल एक्सट्रैक्शन इज यूज्ड. सिमिलरली ट्यूब ऑयल्स के अंदर एस्फाल्ट जो कंटेंट है उसको रिमूव करने के लिए वी यूज सुपरक्रिटिकल एक्सट्रैक्शन. द एग्जांपल दैट आई गिव, एक्सट्रैक्शन ऑफ फ्रेग्रेंस फ्रॉम नेचुरल प्रोडक्ट्स. आपको पता नहीं होगा शायद दैट रोज, आप लोग जो रोज वाटर एंड ऑल दोस थिंग्स दैट यू आर यूजिंग, इट माइट बी एन एक्सट्रीमली डाइल्यूटेड फॉर्म ऑफ what original rose water is. Pure rose के अंदर से जो extract आपको मिलता है, 1 kg or 1 liter of that extract is costing in lakhs, might be 5-10 lakh rupees or even more than that, because that is a pure component. It contains just the fragrance components from your rose. जब इतना costly है, I'll just tell you along with that one thing also, why these things are very costly. Because the percentage of fragrance in a rose petal is very less. Point में रहता है generally 0.1%, 0.2%. It means आप 100 kg rose को process करेंगे, you will might be just get 0.1 kg or suppose say 100 grams of your extract material. That is the reason why these products are very costly. So for such costly products, supercritical extraction is feasible. Okay. Similarly, extraction of aroma and oil from spices. जो डिफरेंट स्पाइसेस रहते हैं उसके अंदर से हम लोग जो स्पाइसेस के एक्सट्रैक्ट्स रहते हैं, वी कैन collect these, we can extract these components from spices as well as oils. Okay, so for that also we can use supercritical fluids. Purification of vitamin intermediates, जो pharmaceutical products है, food grade items है, वो सारी चीजों के purification के लिए, extraction के लिए also you can use supercritical fluid extraction because the temperature is not very high. आप लोग normal distillation नहीं कर सकते चीजों के अंदर because the temperature in distillation would generally very high, or else you need to go for vacuum distillation जहाँ पे temperature is reduced. But supercritical extraction के अंदर फायदा ये होता है that these products are obtained in very pure form. Okay, next please ma'am. So applications of SFC, SCFE, that is all it is. So I hope in a very short span of around 45 minutes, I told ma'am that I will take around 45 minutes and just one shot of 45. The concept of supercritical extraction is clear to you all guys. We had the flow, like we try to understand what is extraction, what is the limitation, what are the drawbacks of extraction, और extraction के drawbacks को overcome करने के लिए हम लोगों ने किस तरह से supercritical fluids के properties का advantage लिया. We studied what is supercritical fluid, supercritical conditions, advantages of supercritical fluids, also the disadvantages. We saw some examples of the commonly used supercritical solvents. फिर हमने देखा what is the general flow sheet or general process description of a supercritical extraction. So there are some specific examples for जो मैंने अभी बताया आपको, deasphaltation of lube oils as well as decaffeination of coffee. These are some specific processes which engage supercritical extraction. Specific examples where supercritical extraction is employed. They are very well known and they are used commercially large scale पे use भी होता है, but because of the limitations of time we are not going into that. So now I leave the floor open to the students. अगर इतना समझने के बाद if you are having some doubts related to this particular thing, I think the students can come up with the questions and might be Divya ma'am can just lead the session.
Yes sir. Thank you so much, sir, for discussing regarding the supercritical extraction in such a elaborate manner, but yet very interesting way. Now, I would request students to please write your queries in the chat, so I will convey to sir. Well, yes, sir. There is one question from Yuvraj Chauhan. In pharmaceutical industry, how to get 100% separation and extraction?
Okay, so I think the last topic that I mentioned, that will actually cover this. As I mentioned, that vitamins as well as food grade pharmaceutical products, all these things, they are having the biggest, you can say, disadvantage. The biggest care that we need to take place is that these products are highly heat sensitive. बहुत ज़्यादा heat sensitive होते हैं. Similarly, different products that are obtained from fermentation से आप लोगों को जो products मिलते हैं, these products they are in very dilute form. काफी dilute form में होते हैं. So to remove these components, to remove these solutes from the solution, might be where it is very dilute, या फिर आपको कहीं से ये components remove करने, and these products are extremely heat sensitive. You generally cannot use normal distillation because normal distillation के अंदर the temperature is very high and these products are prone to get thermally cracked. Thermal decomposition हो जाएगा and the product would denature. उसकी जो properties है that would be lost. As a result of which, अगर आपने देखा हो यहाँ पे, for example, if we talk of xenon का example देखा था, temperature is around 15 degree Celsius, 15-20 के आसपास कुछ था temperature. So 20 degree Celsius के ऊपर मैं xenon को लेके जाऊंगा, if the pressure is extremely high, pressure जो है उसको भी अगर range में लेके जाऊं, so xenon can separate some components of pharmaceutical grade at a temperature might be around 20 or 20 degree Celsius पे, 20-25 पे, these pharmaceutical products would be very much safe. They would not get thermally degraded. So that is the reason why I said, for pharmaceuticals as well as food grade products, this can have a very good scope. इसका application हो सकता है, लेकिन जैसे मैंने बताया, it has to be economically feasible. जब भी किसी चीज के लिए आप लोग supercritical extraction employ करते हैं, the cost of the product is bound to increase. जो product है उसकी cost बढ़ जाएगी. इसीलिए normal तेल के extraction के लिए for edible oils you cannot use supercritical extraction. But for extremely costly aromatic oils, spice oils, perfume oils, for these things you can employ supercritical extraction. I hope I answered you, Yuvraj.
Thank you so much, sir. There is another question from Jay Mehta. He's asking, is SCFE is used in petroleum industry or petrochemical industry?
Okay, Jay, basically when we are talking of extraction, extraction is used to separate components in a mixture. हमारे पास एक mixture है components का, उसके अंदर से किसी चीज को remove करना हो, for that we use the process of extraction. और extraction process का ही एक advanced version है और a slightly different one is supercritical extraction. When we are talking of a petrochemical industry, see, there are two things. One is petroleum fraction and second one is a petrochemical. Petroleum fraction is something जो हमें मिलता है from the distillation tower. That is your petrol, diesel, kerosene, naphtha, all these fractions, they are known as petroleum fractions. लेकिन ये petroleum fractions को use करके हम लोग जो chemicals बनाते हैं, that is your ethylene, that is your ethene, PVC, all these petrochemicals that you are making, they form in the category of petrochemicals. So all these petrochemicals, they are actually manufactured using unit processes. Chemical reactions hai wo. So chemical reactions, you don't require this extraction. But reaction के बाद, if it happens कि reaction के बाद आपको शायद जरूरत पड़े कि आपका जो reaction mixture है उसके अंदर से आपको अपना component remove करना है, you want to remove your final product from your reaction mixture, you can use extraction. But technically speaking, I'll tell you one thing. जो distillation, जो petroleum fractions है, petroleum products है, they are actually a sort of fast moving consumer goods. जो बहुत low cost commodities होते हैं, they are produced in a very large scale, और उसकी cost, commodity की जो cost होती है is relatively very less. As a result of which, generally such costly processes, they are not engaged in petroleum or petrochemical industries. Okay, I hope I answered you, Jay.
Okay, sir. So that's for all. I just check chat.
Yeah.
Okay, sir. Students are very much appreciating. And yes, there is one last question. Can we use for all materials, especially CO2, if there is no side effect on the organic CPDs?
Yes, see, as such, that's what I said. In most of the industry as of now, the scenario that I'm talking of is might be some years back, but till now also, when we get in touch with different industries and some organizations which are actually using this supercritical extraction, CO2 is one of the most commonly used supercritical solvent. As I said, it does not have any particular limitation. Uska jo temperature and pressure hai, they are easily attainable, they are non-corrosive, it's non-flammable, easily available, and it's a low cost commodity. So as such देखा जाए तो CO2 is having a whole load of you can say advantages for being applied in almost any supercritical extraction. But as I said, जो xenon हमने लोगों ने देखा था, that is having relatively lower critical temperature as well as lower pressure, but its availability was relatively less. Flammable नहीं था, it is having no other issues, but वो flammable भी नहीं था. But the only problem was easily available नहीं. Easily available नहीं है. The reason is it's not being used to such a large extent. So suddenly large supercritical extraction units come up and they want to use xenon as a supercritical fluid. In that case, उसका production बढ़ेगा, so its cost is going to come down. Its availability is going to go up. उस case में we can also try for xenon. But as such, CO2 as of now is one of the most widely used solvent and it does not have any limitations. So almost I think we can use for any particular process, we can use supercritical CO2 as the supercritical solvent. I hope I answered you.
Yes, sir. This question was from our international student Tefera. So she has.
Oh, great.
Okay, sir. So I think this is all. Ritesh sir, am I audible? Dr. Ritesh Palkar.
Yes, ma'am, you are audible.
Yes, sir. I request you to please give the vote of thanks. Sir, there is some network issue. Ma'am, there is some network issue. Please give me a second.
The opportunity for all of us to listen a new topic from you.
Yeah. Thank you, sir.
Because supercritical extraction, it's advanced technique in the unit operation and in unit process. And the way you have explained the topic, which is somewhat difficult to understand, right? I really appreciate your efforts because delivering the topic to the diploma students as well as UG student, it's very difficult. The way you were delivering from last 1.5 hours, so it's really appreciable, sir, because the way you started with the fluids and then you stopped with the application part, the coffee bins and all these things. It's a really dynamic lecture class from your side, sir. And if you, with your kind permission, I want to share some more aspects of it, if you permit.
Sure, sir, definitely.
Yeah. Just for the information of students and for our there is a professor from ISC Bangalore, Professor Giridhar Madras. He's working on the same in the same field, supercritical extraction. I hope all of us are aware about it. So I'm fortunate to meet him and his student as well, who is associate professor in VNIT Nagpur. So they are working. That means they worked in the field of supercritical extraction for biodiesel production. So it's quite difficult to work in this field, and what we require is the knowledge which is shared by Williamson right now. If you are not aware about these terms, applications, and the different criteria, then you will not able to work in this field. So though it is a field of wide application and somewhat difficult, and I hope sir might have discussed this is one of the costlier technique, right? So at the same time, when we have that same boiling point, same temperature, critical temperature, critical boiling point, critical temperature and pressure. So it's quite difficult. But sir, I feel this information is very, very useful for to our students as well, since you are dealing to the grassroots points, I can say, starting with the fluids and then what is temperature, pressure and applications as well. So I really like this presentation as well as your, I can say, the talk, sir. So thank you very much for this. And I hope we will continue this repo with the discussion, since for the information of student, William sir, he is frequently visiting our university for different kind of works, and Jitesh sir and Divya ma'am, they are also inviting him for the expert lectures as well as our other official documentation or documentary purpose as well. So William sir is very close to our department, his inputs. And one more, if I'm not wrong, whether Jitesh sir has explained this and shared this with students or not, he is a sportsman. He is a
yes, sir,
referee
definitely,
for the
sir.
football. Yeah, he's referee for, if I'm not wrong, he's associated with different Indian clubs. And for the information of our international students, because they are very much close with to the football, and sir is also a person who mentor the sport persons like in the football or some other things. So thank you very much, sir, for this opportunity. I hope this will helpful for everyone. Yeah.
Thank you so
Over to
much.
you, Divya.
Yes, sir. Thank you so much, Dr. Ritesh Palkar, sir, for giving a vote of thanks. Now I would like to invite Mr. Jitesh Joshi to please address the speaker of the session and our students.
Yeah, thank you, ma'am, for giving me this opportunity. And I also would like to thank William, sir. I just remind my days when I'm a student, when I was student of yours, William, sir, in my master's. And till this webinar, I'm getting too much good fragrance of your knowledge, and my all the student getting this kind of knowledge. Thank you, sir, and thank you, Ritesh, sir, for vote of the thanks. Thank you, Rajesh Patel, sir, for allowing me permission to create this good webinar and knowledge sharing session to all of my students. And thank you, Divya ma'am, for I can say you are the only person to make this kind of to arrange and also making this good webinar to all of the students. Thank you. Thanks students to also for joining till the end of this session. And I'm hand over this mic to Divya ma'am.
Thank you so much, sir. And Williams, sir, students, I should announce this. That's me and Jitesh, sir. We both are his student. He used to teach us He used to teach
Yeah.
us in masters,
Yes, ma'am.
advanced petroleum and petrochemicals. So that subject he used to teach us. Yes, sir. Please.
Yes, so finally, again, thank you very much, Divya ma'am, as well as Jitesh sir, for coordinating these things and giving me an opportunity to talk to the diploma students. Actually, it's one of my biggest fantasies to talk to students, young budding engineers, whether they are from diploma as well as degree engineering, and I ensure that I stay in touch with these guys because what I feel is fundamentals of any subject, especially subjects like mass transfer and different unit operations, they are very important. So for all those students who are there, always keep your fundamentals and basics clear to ensure that you have a good future in chemical engineering or in any other aspects of life. As ma'am already mentioned, I am associated with football. I am a national referee for football, and currently, in fact, I am in a posting. That's the reason why you see a lot of difference in the poster or play card that you have seen, and right now when you are looking at me, there's a lot of difference. So that is the reason. And as ma'am also mentioned, I do have a YouTube channel where I try to put up different videos where I can clear the fundamentals of different students in many core subjects. So if ma'am can just later share that last slide, in that I have mentioned my credentials as well as the details of my Facebook page as well as the YouTube page, YouTube channel. So all the students, if you can just go to that channel and you can just scroll down to the playlist of mass transfer operations. Mass transfer operations ke andar, if you can just go down and look into the different topics that I have put in, I have tried to ensure that the students get an easy understanding. As a result of which, I have put up the medium of communication. I have kept as English as well as Hindi, so that in fact, because many outside state students have also contacted me, so Hindi as well as English is the mode of language that I've used, and around 20-22 videos have been put up for only mass transfer operation. Some other videos for PRPC. So it would be great if you can just go to those videos. You can clear your concepts, and your feedbacks is always something that motivates me to do more. I keep on doing videos based on the topics which students put up in the comments that they request a video on particular topics. So I try my best possible to do it. So with that, I would like to thank you all once again for giving me this opportunity. Thank you all.
Thank you so much, sir. We hope for the such a collaboration in future as well. Thank you so much.
Sure, ma'am.
Yes, sir.
Thank you.
Thank you. Students, your next session will be from 12:30 p.m. onwards. So I will be sharing the link. Till then, you people can leave the meeting. Thank you, everyone, for being such a nice audience.